wrapping up our classes on indices. I'm going to give you a summary of everything we've been doing so far, from rule 1 to the last rule, and this I call advanced indices. Now, from what we've learned before now, when you have a power of indices being multiplied, you will add them together. Division, you will subtract the power. When you have a power in the brackets being multiplied by another power, you multiply the power. When you have a digit or an entity that is raised to the power of 1, your answer is that same entity. When you have a power of 0, your answer will always be 1. And when you have a situation like this where we have, for instance, a over b to power of m, that m will cut across both the numerator and the denominator. When you have a negative indices, you are going to have the inverse, which is 1 over the number and the power. Then when you have these fractional indices, the one that is at the denominator will come forward, y is going to be the power of the numerator. So I expect us to master this rule, and we should be able to apply them in any question that is relevant to them. Now let's look at these examples. Example 1. When you have x to the power of 3 multiplied by x to the power of half, that is 1 over 3. How do you handle this? It's going to be equal to x power of 3 plus 1 over 2. Now, this is the same thing as x 3 whole number 1 over 2, which is the same thing as x 2 times 3, 7 plus 1, 6 plus 1, 7 over 2. Okay, let's have one more example. If you have x to the power of minus 2 divided by x to the power of 4, how do you handle this? It's going to be the same rule as the divisional rule. We are going to have x minus 2 minus 4, which is going to be equal to x minus 6. Okay, let's have example 3. What about if you have 5x squared or x cubed, as the case may be, to the power of 3? This is going to be equal to 5 raised to the power 3. Now, this is what will happen. You are going to address this entity as different entity, 5 separately and x separately. That's why you're going to be having 5 raised to the power of 3 bracket x cubed raised to the power of 3, and this will give us 5 times 5 times 5 to the bracket of x raised to the power of 3 times 3. Final answer will be 125 x is the power of 9. Okay, let's look at our example 4. In this scenario, if you have 2x cubed raised to the power of minus 2, what you are going to be having is going to be 1 over 2x cubed. Now, this will now be 2. Do you get it? So we have 1 over 2 raised to the power of 2 bracket s cubed times 2. Okay, which is equal to 1 over 4 x raised to the power of 6. And that solved the problem. Example 5. We have x raised to the power of 10 divided by x raised to the power of 2 raised to the power of 1 over 4. How do you address this? It's going to be equal to x 10 minus 2 raised to the power of 1 over 4. It's going to be equal to x raised to the power of 8 multiplied by 1 over 4. Finally, we are going to have x raised to the power of 8 over 4, which is same thing as x raised to the power of 2. You can see this is purely simple, completely simple. Number 6, you have 9x raised to the power of 4 over 4y raised to the power of 2, everything raised to the power of 1 over 2, or half. Now this is what you're going to do. You're going to separate the two. For instance, this has to do with this particular rule. This time around, you're going to be having 9 root 9 multiplied by the root of x raised to the power of 4 over root 4 multiplied by the root of y raised to the power of 2. From this, we move on to this will become 3. The root of 9 is 3 brackets x, excuse me, three bracket x raised to the power of 4. Cover this root become half. So we are taking it back. The same thing is applicable to this, reduce to 2 y raised to the power of half. Having achieved this, let's move on. Now, the same principle we apply to this place, let's reapply it. So we are going to be having 3 x raised to the power of 2. Do you know how we come across these two? Because 4 times 1 over 2 is equal to 2. So that's what I've just applied to this one, over 2y. And this gives us our final answer. Number 7, if you have x raised to the power of 1 over 4 divided by x raised to the power of 1 over 2. How do you handle that? This is what you do. Equal to x 1 over 4 minus 1 over 2, which is equal to x. Now, at this junction, you find the LCM of 1 over 4 and 1 over 2. So our LCM should be 4. 4 in 4, 1. 1 times 1, 1. Minus 2 in 4, 2. 2 times 2, 4. Two times 1, 2. So the next step, we're going to have x raised to the power of 1 over 4 minus. Okay, let's move on. Number 8, example number 8. What about in a scenario where you have 2 raised to the power of 4 multiplied by 1 over the cube root of 2 multiplied by 2 raised to the power of minus half? what we are going to have in this place is going to be equal to 2 raised to the power of 4 multiplied by, now you take this one back to a normal standard indices, which is going to be 2 minus 1 over 3 as a power multiplied by 2 minus 1 over 2 as a power. Now from this we have 2 raised to the power of 4. We have 2 common to all, and that is taking us back to log 1 minus 1 over 3 minus 1 over 2. This is like a fraction, like 4 over 1. Do you understand that? Now from this place, you just find our LCM. Let me address this one first. Our LCM here should be 6. 6 divided by 6. 1 divided by 6, 6. 6 times 4, 24. Minus 6 divided by 3, 2. 2 times 1, 2. 6 divided by 2, 3. 3 times 1, 3. So when you sort this out, you're going to have 19 over 6. Okay, so final answer is going to be equal to 2 whole number 2 raised to the power of 19 over 6. This is pure indices. Number 9. In a scenario where we have x raised to the power of 4 over the cube roots of 8x. How do you handle this? This is equal to x raised to the power of 4 over 8x 1 over 3, because this is the cube root, okay, which is equal to x raised to the power of 4 over 3 the cube root of 8 x raised to the power of 1 over 3. 1 over 3. Is that clear? Good. Now let's move on. We're going to have x raised to the power of 4 over 2x, because the cube root of 8 is 2. 2x raised to the power of 1 over 3. Now from this place, we are going to divide this. We're going to minus the power of this from the power of this. Do you get why we're going to do that? Let me give you an insight. Okay, from this point we have x raised to the power of 4 minus 1 over 3. Literally there is 2 here, okay, which is equal to x raised to the power of 3 whole number 2 over 3 over 2. Finally, x raised to the power of 11 over 2 is our final answer. That is 3 times 3, 9. 9 plus 2, 11. 11 over 3. The final example I want to address before I say goodbye to this topic is example 10. Okay, where we have x raised to the power of 5 over 100 3 over 2 as the power. Now I told you from this we are going to split it up. They will have the same power addressing them. So we have x raised to the power of 5 bracket 3 over 2 over 100 bracket 3 over 2, which is equal to x raised to the power of 5 times 3 over 2 over 100 3 over 2, which is equal to, now 5 times 3, 15. So we have 15 over 2. So we have x raised to the power of 15 over 2 over, now 3, the power of 3 over 2 to this 100 is the same thing as when we have the root of 100 to the power of 3. So x 15 over 2 over the root of 100 is 10. 10 raised to the power of 3. So finally, we have x 15 over 2 divided by 1000, because 10 times 10 times 10 in 3 places, 10 times 10 times 10 is equal to 1000. And by this, we've come to the end of indices. Thank you so much.